For question 62, we've got the combustion analysis of 5.214 grams of a compound produces 5.34 grams of carbon dioxide, 1.09 grams of water, and 1.7 grams of nitrogen. If the molar mass of the compound is 129.1 grams per mole, what is the chemical formula of the compound? And again, in this combustion analysis, we had a sample that was carbon, hydrogen, nitrogen, and oxygen. We don't know the ratio, right? It could have been A, B, C, D. It was burned in the presence of oxygen, and it produced carbon dioxide, it produced water, and it produced nitrogen. The mass of this and this and this are all greater than the original mass of the sample because it combined with the oxygen during the combustion of the reaction. So what we need to do is break down this mass and turn it into moles so that we can find the moles of carbon, hydrogen, and oxygen, and nitrogen, and then find a mole ratio from this sample. So much like the last problem, we're going to take the 5.34 grams of carbon dioxide and turn that into moles. We're going to take the 1.09 grams of water and turn that into moles, and the 1.7 grams of nitrogen and turn that into moles. So we know the molecular weight of carbon dioxide is 44 grams in 1 mole, water is 18 grams in 1 mole, and nitrogen is 28 grams in 1 mole. So after step 1, we've got 0.121 moles of CO2. I have also 0.0606 moles of hydrogen and 0.0607 moles of nitrogen. Now I need to find the moles of carbon, hydrogen, and nitrogen. So in 1 mole of CO2, I have 1 mole of carbon because there's 1 carbon atom. In 1 mole of hydrogen, I have 2 moles of hydrogen atoms. And in 1 mole of nitrogen, I have 2 moles of nitrogen atoms. So I can see that I've got 0.121 moles of carbon, 0.121 moles of hydrogen as well, and of nitrogen. So now we can do the mole ratio of carbon, hydrogen, and nitrogen, but we're missing one more component. We're missing the oxygen. So I need to find the mass of all of these so that I can go back using the mass of the original sample and find what's the mass of oxygen that was in the original sample. So I know that carbon is 12 grams in 1 mole. I know that hydrogen is 1 gram in 1 mole. And I know that nitrogen is 14 grams in 1 mole. So on a mass basis, I've got 1.456 grams of carbon. I've got 0.121 grams of hydrogen and 1.7 grams of nitrogen. My total mass is 5.214 grams. Of that, I have 1.456 grams of carbon. I have 0.121 grams of hydrogen and 1.7 grams of nitrogen. So when I subtract, I'm going to find the mass of oxygen of approximately 1.937 grams of oxygen. Now I can find the moles of oxygen and get to work at finding the mole ratio. 1.937 grams of oxygen at 16 grams per mole. And I see that I also have 0.121 moles of oxygen. Now, this is an unusual case in that all of the moles are equal, and it kind of makes finding the mole ratio pretty easy, in that our moles of carbon, hydrogen, nitrogen, and oxygen are all 0.121. So with 0.121 moles of carbon, 0.121 moles of hydrogen. I can still work through the steps, that's always good practice. And 0.121 moles of oxygen. Divide by the smallest number. So divide all of them by 0.121. And as you obviously can see, that leaves me with 1 mole of carbon, 1 mole of hydrogen, 1 mole of nitrogen, and 1 mole of oxygen. So my empirical formula is CHE-106-HQ3.62. And I can come up with my empirical formula weight, right? Carbon is 12, hydrogen is 1, nitrogen is 14, and oxygen is 16. So my empirical weight comes up to be 43. Well, my molecular weight is 129.1. Divide that by 43, right? How many times does that go in there? That'll tell me how many times I have to multiply my empirical formula. And I see that that goes in there 3 times. So I need to take my empirical formula, C1H1N1O1, multiply it by 3 to get my molecular formula of C3H3N3O3, which looks like choice A.